Hello, ladies and gentlemen. Today we are going to take a look at some basic triangle facts and facts about angles. For this, you're going to need your notes, especially those foldables, something to write with, and a calculator. So our learning goals today are to classify triangles according to their measures, and eventually we'll be proving theorems about triangles, but for right now we just want to become familiar with their properties. So remember what you already know about a triangle. The whole idea or the whole definition of a triangle is that it's a polygon with three angles and three sides. So once we establish what a triangle looks like, then we can actually work with it. Your classification foldable should look like this. In class, you picked up one of these. We're not going to take the time to go over each and every one of these words because you've seen them before, and it's pretty much filled out in that foldable. But understanding that angles are a way that we can classify triangles as well as sides. So every triangle can be given an angle classification and a side classification based on what's happening with the angles or what's happening with the sides. So keep that in mind when we go ahead and start classifying our triangles, that we will be using several of these pieces of information here to name one triangle. So if we were going to classify a triangle by its sides, don't write this one down, but this is sort of how it all ties into what we've been talking about here. If we have a triangle that we don't exactly see, but we need to make a graph here, I'm going to go ahead and graph A, B up here, and C over here. This is triangle ABC. The A, the B, and C are in its vertices. And if we had to try to classify this triangle by its sides, what name would you give it? It appears that this side and this side are in fact congruent to each other. We could know for sure if we use that distance formula to find out. That distance formula again is x1 minus x2 squared plus y1 minus y2 squared. We could do that distance formula to find those two lengths to be sure that they're congruent, and especially if we were unsure about the third side here. So maybe we suspect that this is isosceles just by the picture. We could say he's an isosceles triangle, but we could also have to classify him based on his angle. It looks like he could have a right angle down here. How would we be sure? For right angles, for the idea of perpendicular, we would have to use his slope. So that again is the rise over the run. So we'd count up 3 over 3. This side has a slope of 3 over 3, which is 1. This side has a slope of down 3 over 3, negative 3 over 3, which is negative 1. Because those two slopes are opposite reciprocals, yeah, we'd say this is a right isosceles triangle. So using our words, we're going to classify these triangles, whether they appear on plain paper or a coordinate graph like this. We're going to need to classify them based on what we see or what we know. But besides classification, there are also some special facts for triangles that we should be aware of. The triangle sum theorem, the exterior angle theorem, and other helpful hints about triangles. So let's first start with the triangle sum theorem. Many of you have mentioned this already in class, so you must have heard it before. The sum of the measures of the angles in a triangle, so the interior angles in a triangle, is always 180 degrees. That means in this picture, the measure of angle A plus the measure of angle B plus the measure of angle C will always add up to make 180 degrees. No matter what type of triangle it is that we're talking about, if it's isosceles, if it's right, if it's obtuse, the number of degrees in a triangle is always 180 degrees. So using that fact, we can find a missing angle like this example over here. You don't know the number of degrees for angle G, but you do know that the measure of angle G plus the measure of angle F plus the measure of angle H should all add up to be 180 degrees. Then using substitution, we might say like X for angle G, since we don't know it, 115, 35 equals 180. So we would go ahead and use our substitution, our algebra skills here to find out what's missing, or just simply a calculator would do as well. If you just want to subtract those values, 180, subtract 115, and then subtract out the 35 would tell you how many degrees are left. In this case, angle G here is 30 degrees. So using that interior angles theorem is important, but we should also be aware that there are angles outside of a triangle as well. Exterior angles are those angles that are located outside of a triangle. The picture would look like something like this. You might have a 90-degree corner here, or some other number of degrees. These angles here are all angles that are interior, or inside the triangle. This angle on the outside, sort of made by this little tail, that is an exterior angle. He's on the outside. How would we find out the number of degrees on the outside here? Well, we could use the degrees next to it here. Let's say if I wanted to find this exterior angle and I knew this one was 40, well, I'd know this one was 140 because they need to make 180 together, or this linear pair. But if I didn't know 40, how else could I figure out that exterior angle? Well, you can look at the angles inside the triangle to help you figure that out. So let's look at the exterior angle theorem, the middle tab there. Open that up. It should look like this. The measure of an exterior angle of a triangle equals the sum of the measures of the non-adjacent interior angles. So in this picture, I would say something like the measure of angle 1, the exterior angle out here, is equal to the sum of measure of angle A plus the measure of angle B. So notice A and B are the two angles that are not right next to or adjacent to that exterior angle. That's really important. If we were to see this applied in this example over here, we have an exterior angle, 2x plus 10. So the exterior angle equals the sum of the two non-adjacent interior angles. So we can use that fact to set up this algebra equation. And now we can go ahead and solve. Subtract x here. X plus 10 equals 65, and we'll subtract 10, so x is 55 degrees. So we can find x using this fact of exterior angles equal the two non-adjacent interior angles added together. So triangle sum theorem for the interior angles, the exterior angle theorem for the exterior angle, and now some other helpful hints. If two angles in one triangle are congruent to two angles in another triangle, then the third angles will also have to be congruent. That's because we have only 180 degrees in our triangle. So if two of the three are the same, that means the third one will be the same as well. The measure of an equilateral triangle, each angle will have a measure of 60 degrees. Because equilateral triangles are also equiangular. And because of that fact, equiangular means they're all the same. 180 divided by 3 has to be 60 degrees. In a triangle, there can be at most one right angle or one obtuse angle. We can't go over that amount, otherwise we would have too many degrees in our 180 degree triangle. And the acute angles of a triangle are always complementary. They always have to add up to make that 90 degrees that is not taken up by the right angle. Okay, now let's do this example over here. We are about to find the measures of the acute angles of a right triangle. So this one is giving us that last fact we just wrote down, that the acute angles of a right triangle are always going to be complementary. That's because, again, the right angle is 90 degrees, leaving me 90 degrees left over for the other two angles. So we go ahead and take these two angles. Measure of angle A is x minus 6, plus the measure of angle B is 2x, and they have to add up to make 90. So we'd end up with 3x minus 6 equals 90. And then if we go ahead and add those there, 3x minus 6, if we're going to add the 6 over, we have 3x equals 96. 96 divided by 3 then to solve, x equals 32. So that means the x is 32 degrees, not that each angle is 32 degrees, but that means that the x would be 32 degrees. And then we could go ahead and plug those in right here because it does ask for the measures of the acute angles. So if we did measure of angle A would be 32 minus 6. So 32 minus 6 would be 26 degrees. And the measure of angle B would be 2 times 32, which would give me 64 degrees. So we can find those missing measures using the fact that we know that x. All right, very good note taking. Now let's take a look at one more example and how this all plays together here with things that we already know. So this is your last example. You need to make sure that you write this in your notes. We need to find the value of x and y given this picture. Now in this picture we have some parallel lines. Parallel lines mean that you're going to have some congruent angles, if you remember from that chapter. Congruent angles include alternate interior angles, alternate exterior angles. So in between these parallel lines and on this side of that transversal here, this is my transversal, we would know right off the bat that if this angle is 43 degrees, this angle down here would be that as well. So we know that angle X has to be 43 degrees using our facts about alternate interior angles being congruent when you have parallel lines. Now, if we know that fact, that's really nice, but how would we find this Y up here? Well, notice this 75 out here is an exterior angle outside the triangle. That 75 is an exterior angle. That would be equivalent or equal to the non-adjacent interior ones added together. So 43 plus y in that bigger triangle there. So if I subtract the 43, that would give me the y. Y equals 32 degrees. So see how this all sort of plays together. We can have triangles in our picture that we could use. We have parallel lines in our pictures that we can use. All of these facts come back now as we progress throughout this year and start building on actual shapes such as triangles. I want to thank you for taking good notes today, and I'll see you later.